This video is about taking derivatives using the chain rule. When we have a composite function, I've given an example here of 3x to the fourth minus 5x, all raised to the fourth. We could find the derivative by multiplying this polynomial out. We could take the 3x to the fourth minus 5x and multiply it by itself 4 times. That's going to take us some time, and we have a better way. So when we take the derivative of a composite function, we have to identify what we call the inside function and what we call the outside function. So I'm going to let u be g of x. And so I might write this as the derivative with respect to x of f of u instead of f of g of x. And in this case, what I would want to do is find the derivative of f of x, or f of u, and then I want to find the derivative of u, because it's also a function. So we're going to get f prime of u times g prime of x. I like to say this as taking the derivative of the outside function, leaving the inside alone, and then multiplying by the derivative of the inside function. We might also write this as taking the derivative of y with respect to u, and then u with respect of x. So again, we have the chain rule here written another way. If y equals f of u is differentiable and u is equal to g of x, and u is equal to g of x is differentiable at x, then we can say dy dx is dy du times du dx. And again, I like to think of this as taking the derivative of the outer function, leaving the inside alone, and then taking the derivative of the inside function. So let's put this into practice. When we have a function that is a composition of one or more functions, then we first need to identify the inner and the outer functions. So in this particular case, I'm going to think of my inner function as this 5x minus 6, and the outer function to be the something to the 8th. So when I take my derivative, y prime, I'm going to have 8 times this thing to the 7th. So that's taking the derivative of the outside, but I'm going to leave this inside alone. And then I'm going to multiply by the derivative of that inside function, which in this case is just 5. So in the end, we're going to have 40 times 5x minus 6 to the 7th. Let's do that again with this function here. Cosine is my outer function, and x to the 4th is going to be my inside function. So when we think of this, we think the derivative of the outside function, derivative of cosine, is negative sine. And we will leave our inside function the same. And then we will take the derivative of our inside function, which is 4x cubed. So cleaning that up just a little bit, we get negative 4x cubed times the sine of x to the 4th. Okay, so let's take a look at this one here. I'm going to rewrite c as the sine of x cubed, so that I can actually see that one of these is my inner function and the cube here is my outer function. So I'm going to take the derivative of the outer function, but I'm going to leave the inside alone. And then I'm going to multiply by the derivative of the inside function. Derivative of sine, of course, is cosine. So this one here, I'm going to rewrite first as 3x to the fourth minus 5x plus 6 raised to the 1/2 exponent. So when I take the derivative, making sure, I didn't do it up here. We got to be really careful. This is y prime. Making sure that I use the derivative notation. This is going to be 1/2 3x to the fourth minus 5x plus 6 to the negative 1/2 times the derivative, which is 12x cubed minus 5. Okay, for our last example, we've got a table of values here, and we've got a function, h of x, which is a composition, f of g of x, and we want to find h prime of 1 and h prime of 2. So let's just find h prime of x first. That's a composition, so it will be f prime of g of x times g prime of x. So again, that's that derivative of the outside, leaving the inside alone, times the derivative of the inside. So if we're looking for h prime at 1, that would be f prime of g of 1 times g prime of 1. And if I'm looking at my table here, g of 1 is 2, and g prime of 1 is 3, and then we have to take f prime at 2, which is 7. So we get 21. Similarly, if I want h prime at 2, that's f prime of g of 2 times g prime of 2, and we're going to look here. G of 2 is 1, g prime of 2 is 4, and f of 1 is 5. So we'll get 5 times 4, or 20. Okay, so let's take a look at some of these where we're going to combine differentiation rules. So we may, as in this first one, have to use the chain rule, which we do, and so we'll use the chain rule here, but we also have a product, so we're going to have to use both. So the first thing I'm going to do here, remember, these are directions. Take the derivative with respect to x of this entire expression. So I'm going to write it out, but I'm not going to take the derivatives. So I'm going to say the first times the derivative of sine x plus the second, which is sine x, times the derivative of the first, which is x squared plus 2 to the fourth. And now I'm going to go through and take these two derivatives. So we're still going to have our x squared plus 2 to the fourth, and the derivative of sine is cosine. Then we have our sine x, and then our derivative here, and you'll notice how I write this, is 4, and then I fill in. I say take the derivative of the outside function, 4 something to the third, but I'm going to leave my inside function alone, and then take the derivative of my inside function. So you may notice now that we have x squared plus 2. We really only have two terms separated by this positive or this plus sign. So I'm going to factor out x squared plus 2 cubed. That's going to leave me with, because I'm only taking 3 out here, an x squared plus 2 times cosine of x plus, I'm going to remove all of these, so we get 8x sine x. So I often get asked, how do you know you're supposed to do that? The context of what you're doing will let you know that you will need to factor something. So we just like to practice as we go. For this next example, I first want to rewrite this one as e to the 3x times 3x squared to the 1/2, because I know I can use my power rule. So now I'm going to take the derivative. I didn't take a derivative here, I just wrote this as a power. It's also a product rule. The first, and then the derivative with respect to x of 3x squared to the 1/2 plus 3x squared to the 1/2 times the derivative with respect to x of e to the 3x. So when I take the derivative, which by the way, you will eventually skip this middle step, but I'm trying to illustrate what's going on. E to the 3x, and then the derivative here would be 1/2 3x squared to the minus 1/2, and then the derivative of the inside would give me 6x plus 3x squared to the positive 1/2, and then the derivative of e to the 3x is e to the 3x times the derivative of 3x, which is 3. So let's also simplify this one. You can see that 1/2 times 6 is 3. So I should be able to factor out an e to the 3x and a 3. So we'll take out an 3e to the 3x, which will leave me with x over the square root of 3x squared plus the square root of 3x squared. If I wanted to get a common denominator here and multiply this expression here by root 3x squared over root 3x squared, I would get 3e to the 3x times x plus 3x squared over the square root of 3x squared. Again, the context of the problem will let you know if you should do that. Okay, I have one more example here. This is finding the derivative of a quotient. So we are going to have to use the quotient rule, but we also have a composition. So if you're thinking outside and inside functions here, you might think of raising something to the third as your outside function, and your inside function being 3x minus 5 over x to the 4th minus 6x. So I'm going to say first, we'll take the derivative of the outside function, which is 3 times this expression, squared, and then the derivative of the inside, which is a quotient. So that's going to give the bottom, and then the derivative of the top will just give me 3 minus the top. The derivative of the bottom is going to give me 4x cubed minus 6 all over x to the 4th minus 6x squared. So again, just for practice, let's see if we can simplify this a little bit. So I am going to distribute here in the numerator, and I will get 3. I'm going to write this as 3x minus 5 squared over x to the 4th minus 6x squared. This will give me, when I distribute in that numerator, 3x to the 4th minus 18x minus, we will have to FOIL here, minus 12x to the 4th minus 18x minus 20x cubed plus 30. We still have to distribute that negative sign. So let's remember that we're distributing. We'll collect like terms as we go. So I now have 3 times 3x minus 5 squared. I'm going to put these two together and make it x to the 4th minus 6x to the 4th. And then we'll simplify this. So 3x to the 4th minus 12x to the 4th is minus 9x to the 4th. Minus 18x plus 18x goes away. And then we get plus 20x cubed minus 30. That concludes this video on taking derivatives using the chain rule. I highly recommend you learn to say it. Take the derivative of the outside function, leaving the inside function alone, multiplied by the derivative of the inside function.